Hi everyone, my apologies if we do not get to this lesson in class. However, it does build upon what we will be ending the preview of Chapter 3 notes with. I'm just specifying that we're dealing with parallel and perpendicular lines. To quickly review, these notes again are posted on the portal already, but the characteristics of the slope of parallel lines is that they have the same slope, and the characteristic of slopes of perpendicular lines is that they are opposite reciprocals. So that means they have to have opposite signs, and you either flip a fraction upside down or you turn a whole number into a fraction by putting the whole number in the denominator and making the numerator 1. To find the slope, again, just to review, if you were ever given a graph, you would use rise over run. If you were not given a graph and you were just given 2 points, you can use our slope formula of y2 minus y1 and x2 minus x1. Everything that we're going to be working with is going to be dealing with slope-intercept form. So when I ask you to rewrite an equation, please just use slope-intercept form. You can kind of ignore these 2 slides for right now. I'm probably going to pick up with that when we're in class together. But what I would like you to focus on is slides 6 and 7, because we are going to be writing equations of parallel and perpendicular lines. And in this lesson, I'm going to model one of each for all of you. This should be a review from algebra. And if you can write equations of lines like we have done in class, you can most definitely write them of parallel and perpendicular lines. I will be stating a sentence of the given information to write your own equation. So what I want you all to do is write an equation of a line that passes through point -1, 1 and is parallel to 2x minus 3. So one important thing that I will need to use for my new equation is this coordinate. The second thing that I will need to notify is that I'm looking at parallel lines, and parallel lines have the same slope. So the only thing you will ever take from the equation that I give you in the directions is the slope itself. Since I am dealing with parallel lines, I know my slope of the new line also has to be 2. Then we want to identify what we know. So I'm first just going to rewrite out the slope-intercept form equation, and we're going to fill in all of the things that we do know. I know that I have a x and y value for my coordinate. My y value is 1. My slope that I identified from this given equation is 2. My x value from this coordinate is -1. And we are always solving for the intercept, or b. So I just go ahead and start to simplify, and I have y equals -2 plus b. Then I add 2 on both sides to get 3 is equal to b. Please remember that the directions want us to write an equation, so do not stop at solving for the intercept. My equation of the line would be y is equal to 2x plus 3. And we are done. So for parallel lines, the big takeaway is you use the slope from the given equation. I could care less what the intercept is. And we use the coordinate for our x and y values. For perpendicular lines, we are going to have to use the same information, but we're going to have to identify the slope a little bit differently. And so I'm going to do both of these examples. So what I want to look at here is that they are telling us that we want to write an equation of a line that passes through 2, 3, is perpendicular to the line 2x plus y equals 2. Whenever you are given an equation in standard form, please write it into slope-intercept form by isolating y. To get y by itself, I just want to subtract 2x on both sides of the equation, and I'm going to end up with y is equal to -2x plus 2. To figure out a perpendicular slope to what is given to us, perpendicular slopes are opposite reciprocals. So the opposite sign of -2 is a positive number, and the reciprocal of 2 is 1 over 2. So they are opposite signs, and they are reciprocals of each other. And then I'm going to go ahead and use my coordinate as well. So we're just going to be plugging in the known information for our slope-intercept form equation. I know y is equal to 3 from my coordinate. My slope is now 1/2 because I took the opposite reciprocal. And my x value is 2 from the coordinate plus b. Then we're going to go ahead and continue to simplify. So I have 3 is equal to 1 plus b. I'm going to subtract 1 from both sides and find that my intercept or value for b is 2. I need to rewrite the equation of the line using my new slope of 1/2 and my newfound slope y-intercept of positive 2. So there's a little bit of extra work you have to do to find the slope of a perpendicular line. We're also going to practice this example as well. So I have to erase this one so I have some room. Okay, and we are going to start with first just reading through and identifying what we know. I know that I'm writing the equation of a line that passes through -12, 6 and is perpendicular to y is equal to 2 over 3x minus 10. I don't need to worry about rewriting this equation because it is already in slope-intercept form. So the only thing I want to look at is the slope. I need the opposite signs. So because this is a positive 2, 3, my new slope has to be negative. And then I want the reciprocal of 2 over 3, which is 3 over 2. So now I have my slope and I have my x and y values. And we're going to go ahead and start to plug in our known values. My y value is 6. My new slope is -3 over 2. My x value is -12 plus b. To show the multiplication of the fractions, I'm going to write it on the side. And we are multiplying -3 over 2 times a -12 over 1. -3 times -12 is positive 36 all over 2, which will then equal 18. So now I have 6 is equal to 18 plus b. I'm going to subtract 18 from both sides to find that my intercept is -12. To rewrite my equation, I'm going to use my new slope of -3 over 2 and my newfound intercept of -12. And we're done. This will be the last information you are required to know for our quiz that will be this week. It will be on 3.3, the preview of chapter 3, and this section, which is 3.5. Good luck studying, and I hope to see you all soon.